So just quick reading. So linear inequalities written in this form, okay, or these forms. So it's just saying a and b are real numbers, and then as long as a is not zero, like because if a was zero, then this x term wouldn't exist, and then we wouldn't really be talking about a line anymore. So just the reading side of it is, that says ax plus b is less than 0. The next one says ax plus b is greater than 0. The next one says that ax plus b is less than or equal to 0. And the last one says that ax plus b is greater than or equal to 0. So I have a question for you guys. Listen to my question really carefully because I don't want you to answer the wrong thing. How do you tell the difference between the greater than and the less than sign, like when you're reading? Okay, I'm not asking about which way does it open. Like I don't want to know the mouth wants to eat the bigger one. Okay, that's not what I'm asking. What I'm wondering is how do you know to say this is less than? Like when I read that, that's the symbol for less than, and this is the one for greater than. How do you remember which one to say? How do you know that that's the less than sign and that's the greater than sign? What's the way that you remember that? Do you have a mnemonic device? Do you have something you use that help you remember which one's less than, which one's greater than? What do you guys got?
When like the opening is pointed, or like the point of the little greater than less than sign is pointing to the left, so I know it's less than, and when it's pointed to the right, it's greater than. That's how I remember.
Like that, Jacob?
Yeah.
Points left is less than, and then so then the other one would have to be, points right would be then greater than.
Yeah.
Okay. Any other thoughts on that? Thanks, Jacob. So the one that points to the left is the less than, so then the one that points to the right would then be the greater than. Any other ones that you guys use of knowing which way it is? I think that's the exact way that I say it to myself is, which way is it pointing, right? Not which way is it opening, but which way is it pointing? Somebody in first hour mentioned that, the less than looks a bit like an L, right? It's just, kind of a squished L. So that way they remember that that goes together. So, yeah. So if that's something you struggle with, then maybe there's a way to remember. But you guys do need to be reading these to yourself when you go to graph them and stuff like that. So that you're saying it correctly in your head, saying it correctly verbally. That way you're checking it like graphically. So, and so when you're graphing these, so you have your number line. Lord, come on. So there's going to be, if you have the worksheet printed, there's going to be a certain number of tick marks already on there. I don't need you guys filling out like a certain number of tick marks. Like it doesn't need to be completely full. Like when you learn these way back like 7th grade or whatever, your teacher might have been like really strict and saying, fill out the whole thing. I don't need you guys filling out the whole line with all the numbers on it, but I think maybe put 5 numbers on there. The one that we're talking about, and then a couple on either side of it. Generally, you would put the number that we're talking about kind of in the middle, And so then, I'll put a couple numbers on either side. And just be careful with your negatives. I've seen plenty of people mess up numbering with their negatives. And so we start with, because this symbol is not equal to, that means we get the open circle. We talked about this when we were doing the graphing stuff with the domain and the range and stuff like that. We talked about the open dots and the closed dots, right? So the open circle here, right? And then the other side of it is, because this is a greater than, so there's two things we're looking at here, means that we're going to be graphing to the right. Right? So again, if these are things I'm telling you that you already know, then you don't need to write down those words, right? But if it's something that I'm reminding you of, or something that sounds completely new to you, then then you should be writing that down. Okay? I just wanted to bring this up just because it's something we have been talking about, and I wanted to kind of keep it fresh in your mind. In interval notation, we would write that since it's from that left side, the first number we hit is -5. And then the arrow goes to the right forever, right? That'd be positive infinity. And then since it's an open circle, you get a parenthesis on the -5, and infinity is always get a parenthesis. So again, not something we're doing right now. I just wanted to remind you guys of that so it doesn't disappear. Okay. Somebody in first hour asked a question, which I think is a good question to just talk about really quickly. They said that you always draw the arrow in the same direction that it's pointing, here, right? You always draw the arrow in the same direction this is pointing. And yes and no, okay? It depends on how you write the problem. I don't like reading problems like this. It's harder for me to understand it when I put the number first and then the variable. This makes less sense to me. Kind of the same way that when we solve problems, like I will always put x equals 3 rather than 3 equals x. It just, my brain works better that way. That's kind of a personal habit. There's nothing wrong with this statement. This statement, -5 is less than x, means the exact same thing as x is greater than -5. They mean the exact same thing mathematically. The numbers don't care. Okay? But if we want to use that trick that the arrow always goes in the same direction that the inequality goes, then the variable has to be first. If you write it like this, the arrow goes in the opposite direction. So that's something that you need to be taken care of. Okay? I always switch it because I just don't like this. But you could stop here and be done. Okay? But you've got to then make sure you graph correctly from there. So if you're wanting to use that trick that the arrow always follows the inequality symbol, then you've got to make sure you write your answers like this. The variable has to be first. Okay? Does that make sense?
Yeah.
All right. And then if I graph the next one. So when you go to graph a fraction, we don't put fractions on number lines. Okay, like I'm not going to label that 1/2, and then like this is 1/4, and that's 3/4. We don't do that. The reason is there's no set way of how to break down the fractions. Like if I call that 1/2, and then I have 1/4, and then that would be 0, and that would be 1. Like, why did I pick counting by 1/4? Right? There's nothing in there telling me to do that. I very well could have called that 1/2, and then that could be 0, and that could be 1. Right? But there's nothing telling me to do that. Okay? So we do not put fractions on our tick marks. You only put integers on your tick marks. And so to do that, I need to pick the numbers that are around 1/2, like 0 and 1. So those are going to go towards the center of my number line. Then I can put 2 and 3 and then -1. Okay? So you only put integers on the tick marks. Okay? So with a fraction, right, so we want to talk about 1/2. And because it's equal to, right, that means we're going to do closed circle. So we just need to put that closed circle where we think 1/2 is, right? So for me, half would be right there. So you put the integers around it, and then you put the fraction where it should be in relation to those integers, right? If it had been 1/3, then I would have put it over here. If it had been 3/4, I would have put it over there, right? So it's kind of judging on your number line where it should be. And then you always label it as well. So I didn't do that over here with the -5 because it was already on the line. But if we're putting a dot between the two tick marks, then we need to label what it stands for. Okay? So only integers on your tick marks, and then when you're doing fraction, you need to label it special on the dot. And then, because that's less than, right? It means arrow to the left. Again, not that we're doing it, but I just want to keep it in your mind. If I was going to write this in interval notation, the arrow to the left would be negative infinity. And then we're stopping at 1/2. So that gets the 1/2 there. And then the 1/2 is a closed circle, so it gets a bracket. And then infinity is always going to parenthesis. So just seeing that in interval notation again. Again, you guys don't have to do that. I just want to show it to you. We talked about how to tell the difference between less than and greater than. Again, for me, I think about the open circle and the closed circle, I always thought that closed circle is like I'm able to grab the point. I can have that value in my answers. Whereas the open circle kind of represented more like a shield. Like I could only get really close to the number. Okay. So what this means when we write that is that, what are answers to this problem? So numbers that are only bigger than -5 are answers, but not -5. So the very first number in my group is -4.999999. And then any number bigger than that also works. Same thing here. What are answers here is all the numbers that are less than 1/2. So like -10 and -1 and 0, but then also 1/2 is an answer to this problem. So I get exactly that number or any number less than that. Okay. So just kind of hitting on some of the finer points, right, about how we graph these. These two things here may not be things that you remembered or knew. Okay, those things I put the stars on, but maybe you knew all this stuff already. Okay. Anything here you want to talk about before we get into the solving and graphing? This is the part where you guys say yes or no.
Nope.
Nothing I can think of.
Okay. All right. So we're going to solve these, we're going to graph these. Okay, so we should have an answer that says x is less than blah or x is greater than blah, and then we should also have our graph. Okay, so two things I'm kind of expecting to come out of this. We're solving, so we should be thinking about SADMEP as our process, right? really, again, solving inequalities is not much different than solving an equation. There's one little thing that we'll run into that we'll talk about in a sec. So, but our job is to get x by itself. So, all right, so I'm gonna get rid of that 9 first, since it's the subtraction addition side of things. So I get 4x is less than 16. And divide both sides by 4. So that's the division multiplication step. So x is less than 4. Okay. And so if I go to graph that, and just take that number that we got and put it towards the middle of your graph, and then put a couple of numbers around it on the other side. Don't need you to completely fill out the number line, but and then since that's open circle, since it's a less than, and then since it's less than, or I guess since it's not equal to, is I guess the way I should have said that, and then since it's a less than, we want to graph to the left. Okay. So that's what I'm expecting you guys to have for your answers. I want to talk about what this means real quick, and you guys don't necessarily need to write this part down. You may want to, but that idea of like, what does this mean? What are we talking about here? Okay. And so talking about all of these numbers could be answers to this problem. Okay. So something that's less than 4, like 1, it should be an answer to this problem. So if I go and I check 1, so 4 times 1 plus 9 is less than 25. So that's 4 plus 9, which is 13, right? Is less than 25. So 1 worked, right? This is saying that we can't use 4, right? Because it's not equal to 4, right? So why can't we use 4? So 4 times 4 plus 9 is less than 25. Well, 4 times 4 is 16. 16 plus 9 is 25. 25 is not less than 25, right? So that one doesn't work. You see that 4 doesn't make that inequality true. All right, and then numbers that are bigger than 4, they also shouldn't be answers, like 6. 4 times 6 plus 9, which is 24 plus 9, which is 33. All right, and 33 is not less than 25. Right? So we can see that those numbers aren't satisfying the inequality. Right? The numbers that are specifically less than 4 do satisfy it. Numbers that are 4 or bigger don't satisfy it. That's why they're not answers. Okay. And we don't spend a lot of time talking about inequalities in Algebra 2, but inequalities are used a lot in life, right? You've got $50 to go buy your friend a present. You don't have to spend exactly $50. You could spend less than $50 and you're fine, right? But you have like a limit. Okay, so you could spend $47. You could spend $22, right? There's lots of different answers to the question of how much I can spend on this present. In the same way, businesses have budgets. They have $50,000 to spend on a project, right? Well, they don't have to spend exactly $50,000. They could spend $45,216 and they're fine. Okay, they can be under budget. So there's lots of different things that we can think of that are, less than $50,000. And so there's a lot of context for inequalities in real life. We just don't spend a lot of time talking about them in Algebra 2. Okay. Very, very rarely in real life is there one exact answer to the problems that we're working with, with money and stuff like that. You guys good on A?
Yeah.
Look at B here. So we want to follow SAD map, right? You are goof, Peyton, you are. So I'm going to subtract 1 from both sides. Make sure you bring down the negative with the 3. Okay. It's great. Negative 3x is greater than or equal to, and then give me negative 15. All right. Want to get x by itself, so we're going to divide by negative 3. So then x is greater than or equal to, so negative 15 divided by negative 3 would be 5. Right? So x is greater than or equal to 5. So we say, hey, let's check that. Let's see if it works, right? So it says x has to be greater than or equal to 5. Like a number that's greater than or equal to 5 is 10. So 1 minus 3 times 10 is greater than or equal to negative 14. That's 1 minus 30 greater than or equal to negative 14. 1 minus 30 is negative 29. That's not supposed to be 19. Is negative 29 greater than negative 14?
Nope.
Nope. All right. So something's not right. The answer that we said should work isn't working. Okay. Well, what about the other side of it? Right? X is supposed to be greater than 5. Well, what if x was less than 5? So what if x was 0? 1 minus 3 times 0. Well, 1 minus 0, of course, is 1. Is 1 greater than negative 14?
Yep.
Yep. So, right, something's wrong, right? We said the answers were supposed to be bigger than 5, but answers that are bigger than 5 aren't working, right? Answers that are less than 5 are working, okay? So here's the trick with inequalities. Here's the one thing that we got to watch out for. When we divide or multiply both sides by a negative, that inequality symbol has to flip around. Okay? This is by far the most common forgot thing with inequalities. Okay, you can see all the stars I'm putting by this? Okay, understand what I'm trying to get at here? This is important. So because we did this, that had to happen. Okay. Notice that the answer is not negative. That's usually a common misconception with this is that, oh, the answer is negative, I got to flip the symbol. Okay, it's not because the answer is negative, because we did something. Okay, we chose to divide by negative 3 in order to get x by itself. That's what changes this. And the reason it's changing is because if we don't change it, our answers are wrong. I mean, it's really as simple as that. There's no other reason that when we don't do it, we get the wrong answers. And when we do it, we get the right answers. So let's do it. Okay. But it's super easy to forget. And of course, if I go to graph that, Brooklyn on the 5, should I do an open circle or closed circle?
Closed.
Okay. Thank you. Alex, should I do arrow to the right or arrow to the left? There, Alex?
To the left.
Left? Okay. All right, you guys good with that? Closed circle, arrow to the left? Does it seem like it needs to be fixed? Lucas, think arrow to the right? Why is that, Lucas? Okay. Thanks for letting me know. Waiting on him to type his answer out. And if you would, Lucas, if you can type it into the public one so everybody can see it. You can type it out and then just copy it, or I don't think if you change who you're sending it to, I don't think it erases it. So if it's a greater than, it has to go to the right because those are the numbers that are getting larger. So I guess, Lucas, I'd have you read this. You read that and said it. What's that say? How would you read that to somebody who couldn't see it? Yeah, so right. So you're saying less than now, right? It's not greater than, right? So x is less than 5, so we want numbers that are smaller than 5, right? So yeah, just be careful about how you read that, okay? Or if you forgot to flip it, I don't know what you did there, but yeah, it definitely should be a left arrow since we want to go left. Yeah, there you go. So make sure you're looking there. Cool. Good to work through that though. Clever, you're saying it should be an open circle. So remember, this says less than or equal to, right? So since we can be 5, right, equal to 5, we should do, right? That's me grabbing the number because I can be the 5. I should close my circle. I'm going to close my fist around that and grab that number. The open circles when we can't quite get to it, like you said, but that's when it's not equal to. Should be closed. Oops. Any other things here, guys? Questions? Yeah, sorry, Clever. It's good to get those little misconceptions out. Oh, yeah. Oh, okay. Interesting. Okay. All right. Let's see where. Oh my. Okay. So I'm gonna. Good Lord, we really worked through time here. I'm gonna do just parts of these real quick. With a problem like C here, you have a job of getting X on one side or the other. It doesn't really matter which way you do it. Generally we've talked about moving the smaller one over, and so that would mean that we'd have to move the numbers to the other side. And so that would give me 2x on the right, and then 8 on the left. And then, of course, I just divide by 2. So here we're in that situation where now for me, it's written backwards. I don't like this. And if I was going to go to graph this, I think there's a good chance that if you don't move it around, you guys might make a mistake when you go to graph it. So just being aware that I would prefer to have it this way, and then I'm going to have a better chance of getting it graphed correctly if I do that. I think that's my personal opinion. you guys want to leave it this way, it's fine. Mathematically, that's the right thing to do, or it is the right answer. But again, it may not make as much sense to you, so maybe it's not a good idea to do that. So as you go to flip it, though, if you're going to flip it, you have to make sure that that symbol also flips around, okay? So that it stays opening towards the X like it was. So make sure that if you do that, okay? So just something to think about and how you write your answers. Dang it. I do want to go through this one just really quick, just because of the fraction, if you guys got a minute to stick around, but I understand if you don't. Sorry about the time. We want to get x by itself, so I'm going to subtract 4 from both sides. And we talked about fractions yesterday. Remember that we're thinking of it as pieces. The denominator is dividing. I want to get rid of that 2. So that's the first thing I'm going to do is multiply both sides by 2 to get rid of that. Again, its job is to cancel the 2, not to make that a 6 on the top. It does not do that. And then I get 30 over here. Then when I go to divide by that -3, all right, I'm dividing by a negative. So that's going to flip my symbol in the middle. Okay, so I'm going to do that in a different color just to highlight that. Okay, so I get x is then greater than -10. Okay, so it's working through a fraction again, making sure you flip your symbol. Okay. Notice how I'm saying symbol, not sign. Sign generally refers to the sign of the number, right? That it's negative here, the number is positive. This is an inequality symbol, not a sign. So using a different word, so I'm not talking about the sign of the number. So, okay. Again, the worksheet that you guys had a while ago, the back of it is your homework. It's on the Google Class again. Okay, so if you didn't print it before, or it's there again for you guys. Okay. Anybody need anything?